Welcome to Developer Service YouTube channel. On today's video, we're going to be talking about asynchronous processing in Python. Concretely, we're going to be focused on multiprocessing, but for your references, what kind of possible other libraries it exists for asynchronous processing in Python? Well, we have async, we have twisted, we have getEvent, we have tornado, and we have the built-in multiprocessing, which you're going to be seeing in this video. Which is the big advantage or big strength of the multiprocessing? Does it provide true parallelism? It's a very familiar model. Of course, it has its own limitations with geo limitation, and it also has a higher overhead. It's typical use when we really have a lot of CPU intensive tasks and we really want to do true parallel processing. As you can see from this table, there's several other different libraries, and of course your use case depends on your needs. But for the focus of this video, we're going to be focusing on the built-in multiprocessing. So for the purpose of this video and for our testing, we are going to be using three different files for three different executions. First, we have the simple sequential processing, and we're going to be processing the prime numbers of a certain range. Then we have the multiprocessing, which will use the multiprocessing library and do the true multiprocessing parallelism. And of course, we have a main file that will compare the execution time of the sequential and the multiprocessing, and will give us a speed up effect of using multiprocessing. Let us start with the sequential processing. So first, we are defining a function that is checking if a particular number is prime. It receives the integer and returns true or false if it is not. We're doing the calculations to check if it is a prime number or not. Then we define a function that counts the number of primes in a specific range, which receives a start and end range, and returns an integer of the number of primes that are in this range. So of course it goes through the range, uses the s prime that we defined before, and it returns the count. So then we have the function that runs this processing sequential. So processes each range that receives in a sequential fashion. So it receives a range, which is a tuple that contains the start and end of each range, and so it iterates over each of the starts and ends, and it processes the results and appends that to the results. Then we define our main function, which executes our whole code. So we are defining 20 ranges of 10,000 numbers, each starting at 1 million. So this is defined defines the range. We're logging in the time, so we're defining our start time. We'll be running the sequential. We're defining our end time. Then we're going to print the results, and we're also going to print the time that it took to run the calculation of the prime numbers in a sequential fashion for the 20 ranges. So if we execute the code, so we can see that it used the particular range to calculate for the prime number calculation, and it took 1.06 seconds for the sequential calculation. Now let's take a look at the multiprocessing implementation. So we have the same s prime function, the same count primes in range function, but now instead of the run sequential, we have a run multiprocessing, which still receives a range, but it processes all the range in a parallel fashion using multiprocessing. How does it done that? Well, first we determine the number of processes so that we can, the number of CPU cores, so we can match the number of processes to that. We create an execution pool, which we say that the size is the number of processes that we saw before, and then star map lets us execute the function and unpack also the range as the parameters. And so this is giving us our parallel execution. So each of the ranges goes into a different execution, and all of the different executions are part of this pool, but each of them can run in parallel because they're running inside this pool, and they don't need to wait for each of them to finish. So again, in the main function, we're defining the ranges. Start time, we run the multiprocessing, end time, and we print both the results and the execution time. So now if we run the multiprocessing, and you can see that we are similar range to what we defined before, but we see that now instead of 1.6, it runs 0.5 seconds because it ran into parallelism fashion. Now using our main file, let's compare the execution of one with the other. So we still have the s prime function, the count primes in range, We have the same run sequential that we saw in the sequential.py. We have the run multiprocessing, which is in the multiprocessing.py. And now our main function, still the number of ranges. And we're logging in the start and end time of the run sequential. This is all the code for the run sequential. We're logging in the time and the execution for the multiprocessing. And then we're going to be calculating the speedup factor. So if we have a multiprocessing time, which means if the multiprocessing as an execution time, then the speedup is going to be the sequential time divided by the multiprocessing time, and that will give us the speedup in terms of how many x increase in speed does the multiprocessing gives in return in regards to the sequential. And of course, if it's not zero, that means it's actually too short the multiprocessing time to calculate the proper speed. So if we run this code and we see this corresponds to our latest execution. So you see the sequential for that range 1.1 seconds, the parallelism multiprocessing 0.5, so that gives us a speed up of 2.04 x in terms of the multiprocessing for the sequential. As you can see, it's not very complicated to implement multiprocessing with true parallelism in Python project. We just need to use the multiprocessing pool and then run the function, and we can use star map to unpack arguments that it needs to be unpacked for that function. But someone pretty much is creating a pool and then running the execution inside that pool. What is the big advantage is that it processes in a synchronous fashion, but also in a parallel fashion. So if you have, as you saw in the initial graph, if you saw real parallelism processing that you need to do that runs in parallel, very CPU intensive tasks, you can use the multiprocessing module to really speed up your execution. Like this video if you like this content, subscribe for more content about Python, Django, and AI, and until next time, happy coding!